tabulate is in many respects the key operation that a finite element provides. And what it does is, so remember, a finite element is essentially a set of basis functions defined on a cell. And what we're going to do in the finite element method eventually is integrate some function which is made up of basis functions. And we're going to integrate it using numerical quadrature. And so the logical consequence of that is that you need to be able to evaluate basis functions at quadrature points. And that is what tabulation is. So tabulation is taking for a particular finite element and a particular set of quadrature points, the values of all of the basis functions at those quadrature points, which produces a table, which is number of basis functions by number of quadrature points, or the other way around. I'd have to check the documentation. And so that, hence the name tabulate. So that's what this guy does mathematically. And actually, tabulation is very, very closely related to the operation that we discussed yesterday of constructing the basis functions. Because if you remember this definition of the basis, what is this? Well, this bit is the coefficients that define the basis functions with respect to all of these monomials, all of these base polynomials. And by the time we get down to tabulate, you know what C is, right? Basis coefficients is already in your finite element. That's known. And so actually, all you have to do is multiply the basis coefficients by the evaluation of these expressions at whichever points you want, which will be the quadrature points. And so the same formula comes to your aid. So the only thing that's different is when we define the basis functions, we were given a set of points V. We knew the right-hand side was going to be I because of the orthogonality relationship that we defined at the beginning, and we didn't know C. This time, we're still going to know the points, but they won't be the node points, they'll be the quadrature points. We still know C because we did them before, and we want to know what the values are. And so all you have to do is evaluate a van der Waals matrix using the van der Waals matrix function you already wrote, and matrix multiply it by the set of coefficients you already knew. Life is easy.